Hello, we are going to see how to find the angle between two planes. In my picture over here, we have a green plane that I call pi1 and a blue one that I call pi2. They intersect at a line that I call L, red over here, and they form an angle theta, and that's the angle that we are trying to find. What we know about these planes, and we're going to use it, is the vector that is normal to each of them. Here with green, I'm drawing the vector n1 normal to the plane pi1, and with blue over here, I'm drawing the vector n2 perpendicular to the plane n2. What we want to see is that actually the angle here with red, that they are forming these two vectors over here, is the same that the planes are forming. So it's going to be easy to find what that angle is. To achieve this, what I'm going to do is a new picture where I'm seeing a side cut of the plane. So I see the plane pi2 exactly as a line, together with, that doesn't look good, together with the vector n2 blue. And we also see the side of the plane pi1 and the vector n1 with green over here. So we want to see that this red angle here, theta, is actually the same as we see over here. When we talk about the angle between two planes, we refer to the acute one. So when we find the angle between the vectors n1 and n2, we are going to refer to the acute one as well. So need another color here. This angle over here is actually 90 degrees minus theta, because here with green we have a right angle. Now, if we continue our vector n2 almost to the end of our page and continue the plane over here as well, we have the bigger triangle that has also one angle theta, and the angle over here also has to be 90 degrees minus theta. Now, looking at the smaller triangle with the right angle over here, we said already that this angle is 90 minus theta, so this angle is theta, as we wanted to show. So theta is the angle between pi1 and pi2, but it's also the angle between n1 and n2. And that's what we are going to see in the next example, how finding actually that angle between two vectors is very easy. So now we are going to find the angle between two actual planes. So let me see over here. We're just going to make up two planes. Pi1 x plus 2y plus 3z equals to 4. So this plane over here has normal vector 1, 2, 3, because those are the coefficients that are multiplying x, y, and z. Need one more plane, let's say pi2. I don't know, minus x plus y minus z is equal to 10. This has normal vector minus 1, 1, minus 1. Note that the planes are not parallel, since the normal vectors are not parallel. So they are going to intersect, and then we're going to be able to find what is the angle between them. To find the angle between two vectors, we could use either the cosine and the dot product, or the sine and the vector product, and of course we're going to use the dot product because it's easier. So the cosine of theta is going to be given by the dot product or scalar product between the normal vectors n1 and n2 divided by the magnitude of one of them multiplied by the magnitude of the other one. So let's find what the dot product is. We need to do 1 times minus 1, so minus 1, plus 2 times 1, so 2, minus 3 times 1, so minus 3. So that's for the dot product in the numerator. In the denominator, we are going to need the, oh, what was that? The magnitude of the first vector, that's going to be 1 plus 2 squared plus 3 squared, so that's square root of 14 times, and then we have the square root of 1 squared plus 1 squared plus 1 squared, so square root of 3. So this is minus 2 over square root of 14 times square root of 3. So we are going to use the calculator to find the cosine inverse of minus 2 divided by, and now we need 14 times 3, all of that square root. That gives us an angle of approximately 108 degrees, but we know we want the acute angle because that's how we define the angle between two planes. So 72.0 will be the result, correct to 3 significant figures. So here we can see that theta is 72.0 degrees, and this is the angle we were trying to find.